Good evening, everybody, and welcome to the first talk of this year's Fire and Safety Division's series of lectures. My name is Michael Lyons. I'm the chairperson for this year. We have a big committee, and we have agreed to do quite a number of different things during the year as well. Starting off with a number of talks here. While our first talk, obviously, and the speaker is here, I'm going to mention the second talk, just to put it into your diaries, which is for the 15th of November, and that's going to be to do with water mist and sprinklers. And again, it'll be at 6:30, and again, it will be webcast. One of the work program for this year as well includes a seminar. We're going to have a seminar next year, April 2019, and that's going to be on April 25th. And it's going to be held in Athlone rather than here in Clyde Road, to make it accessible to people around the country. So that just leaves us one last thing to mention is that there is also a workshop seminar being held here in Clyde Road on the 23rd of November. It's free, and it's held in conjunction with the University of Ulster. Professor Ali Nagy. Its title is An Integrated Approach to Fire Safety Engineering, and it's basically about structural fire engineering and design issues to do with the use of Eurocode 1, and there will be a range of speakers. You do have to register. Go on to Engineers Ireland's website. The attendance on the day counts for your CPD. And it's one of a series of partnerships that we hope to keep developing between Engineers Ireland and third level institutions, as we keep an eye on fire safety engineering education and qualifications as we go forward in the next few years.
Sorry, what was the date again, please?
Is the 23rd of November, and it'll be held here at Clyde Road. But you have to register.
It's a Friday.
That's a Friday. All day long, but you do have to register through Engineers Ireland's website to attend on the day of the course itself. And then that takes us to tonight, and tonight's speaker is John Chubb, District Fire Brigade, or District Officer with Dublin Fire Brigade. John's talk will be to do with firefighting in relation to high-rise buildings. These are any opinions are expressed are the opinions of John Chubb, not of Engineers Ireland or of Fire and Safety Division. We also have a lot of people online who are watching, so a big hello to the Fire Brigade in Limerick City and County Council. We can't hear you, but you can hear us apparently. The webcast will be recorded, and it will be made available through Engineers Ireland's website next week, if not the week afterwards. So I would like to hand it over to Mr. Chubb. Thank you very much.
Good evening, everybody. As Michael said, my name is John Chubb. I've been a member of Dublin Fire Brigade for 32 years. And in recent years, we've been working on a high-rise project, well before Grenfell, as it turns out. So what I'm here tonight is to discuss how we've approached that project and some of the findings that we've really arrived at. The first thing I want to say, I'm not an engineer. I'm a professional firefighter. So when we look at perspective, this certainly will not be from an engineer's perspective. So you have to give me a little bit of slack there, if you wouldn't mind. So essentially, the project objectives we've made real simple, because this presentation went on for probably 3.5 to 4 hours originally in Dublin Fire Brigade. So we wanted to examine the problems associated with firefighting in high-rise buildings. We also wanted to identify opportunities for skill and knowledge development amongst our crews. And then we wanted to implement robust procedures and policies for Dublin Fire Brigade firefighters to operate safely and effectively in the high-rise built environment. So this has been very much a group effort, so I'm only one of many. And if you care to look at the list of names, you'll see some of your esteemed members. Niall is right there, who was a really big help to us. We've also got people from the community of smoke management, fire alarm systems, So one of the first things we really realised was this had to be an eclectic mix of people to help generate the type of information we wanted. We really couldn't do it on our own. This has actually turned into 5 separate work streams looking at the emergent themes in more detail. So this was a really big project for us. So really the start off point is captured in this quotation, in that the relevant question is not simply what we should do tomorrow, but rather what we will do today in order to get ready for tomorrow. Because the implications and findings of this project are going to influence Dublin Fire Brigade probably for the next 50 years. So it's that big a project to us. So what did we do to get ready for tomorrow? Well, we defined what a high-rise building is. And when we drill down into that later, you'll notice that everybody really doesn't agree on what a high-rise building is. We also characterised the high-rise problem from the perspective of firefighters. We undertook a performance gap analysis, and we'll be talking about this later on, but we took a really hard look at ourselves as an organisation to see what we needed to do to get better with regard to the challenges of high-rise firefighting. We also identified the workforce skills necessary for safe operation in high-rise buildings, and we determined if our material resources were suitable and sufficient going forward. We took an approach to this as academic as we could. We took a review of best practice, procedures and tactics compatible with the Irish built environment. And that's the thing we found. What was applicable in the UK mightn't necessarily work in Ireland, and certainly what was working in America, because of their differences in the built environment, wouldn't necessarily translate easily to the Irish equivalent. We then carried out a series of scaled exercises. In the last 2 years, we were running at one exercise every 8 weeks. And we actually looked at all different aspects of it, and we'll talk about that, and from the point of view of operational firefighting, and we really examined that very closely and critically to identify where we were in the process. So then we recommended to our Chief Fire Officer at the time, Pat Fleming, what was the best way to roll this out to a workforce of about 1,000 firefighters and officers. So getting back to what is a high-rise building, well, the starting point was our employer's view of it. So what you're looking at there is the definition of a high-rise from the perspective of the Dublin City Council Development Plan. And if you take a look, they define high-rise as buildings over 50 metres and 20 floors plus. They define medium-rise as buildings up to 50 metres. And they defined low-rise up to 28 metres. So if we have a look at that, how it looks on a map, the green section is zoned for low-rise buildings. The area that I've just brought up down at the docks and at Houston Station is zoned for Dublin City Council's view of high-rise buildings. And these slightly red circles are medium-rise. So you can see a vision for the city which really kind of encourages us to believe that we really need to get our act together here pretty promptly to deal with the changing environment. Now, that's one perspective on a definition of high-rise. If you were to look from a fire service point of view, you will find something quite different. If you look at the British Generic Risk Assessment for high-rise buildings, they define it for the purpose of this assessment that a high-rise building is defined as a building containing floors at such a height or position that the deployment of external firefighting equipment and rescue operations may not be feasible. So that was starting to give you an insight of how the fire service is looking at it in the UK. If you go across the Atlantic, and we looked at every definition possible, the Ottawa Fire Service say that a high-rise structure is a structure that's beyond the reach of fire department aerial equipment because of its height and its setback and its location, which is a slight broadening of the way we understand it. They also define it as structures that require unreasonable evacuation times And then they say that structures that pose a potential for significant stack effect, which we're going to talk about later. And then structures that require high-rise tactics. So that's completely different to Dublin City Council's view, because the thing that we have to ask then is the entire perspective of firefighting is what we can reach from the outside. So that's the principal metric applying internationally in the fire service community. So from that point of view, what can we reach? Well, our largest aerial appliance in Dublin right now is 30-metre ladder, and its effective reach is 20 metres when you talk about the position that it has to take on the street. So from that position, 20 metres from our point of view becomes the standard that defines high-rise. So we had to actually look at this much more closely, because we have to understand how we're going to develop tactics, how we're going to develop the required predetermined attendance. So we determined that we can't just say every building in and around 20 metres or above is a high-rise, and we're going to send everything to it. So for that purpose, we needed to classify it further. So what we came up with, we copied the Ottawa model, and we developed 3 types or 3 categories of high-rise, which is going to directly influence our tactics and directly influence the resources or assets that we're going to send to them. So we said a type 1 is equal or less than 20 metres. And in these buildings, we could look at what we're looking at: hotels, apartments, and these buildings can be extinguished externally with our equipment. They are going to be, by far, the most common high-rise incident we're going to go to in Dublin. We realise we're not in New York. We're not in these huge cities with 50 and 60-storey buildings. But the tactics that we have to use for those, right, will slightly differ from the type 2. The type 2 is buildings that are residential above the reach of our ladders. And then the type 3, we go to commercial or mixed developments that are above the reach of our ladders. And each of those will have a very clearly defined approach from a firefighting perspective. So the next thing, I want to talk about the problem associated with high-rise firefighting. So the first one I'm going to touch on is fire behaviour in tall buildings. And you're going to hear me talk about tall buildings now rather than high-rise, because everyone has the vision in some countries that we don't have any. But you have a look, residential high-rise fires, that's if the fire remains compartmented, will behave similarly to fires in ground level enclosures, with one caveat. The effects of wind are actually going to create a whole different environment for our people. So have a look. A wind-driven event requires an inlet and an outlet. And if the firefighters caught between the two, they're in a severely dangerous situation. So if you want to take a look at this fire here in Dublin, this would be a type 1 high-rise. It's clear to see which direction the wind is coming from. From your perspective, it's going from right to left. You don't have much sound, but we'll work on that. What I'd like you to watch is when you hear the pump sound change. What I'd like you to listen to is when the high-pitched whine of a pump goes down. We had a failure of the pump, and I want you to notice the change in fire behaviour. First of all, the smoke colour changes, and when we start to see flame propagation at the window, you're going to see an unusual effect. The flame does not demonstrate typical Coanda effect against the building. You see a horizontal flame coming out. Can everybody see that? You are seeing a wind-driven event. What I want to show you in terms of the firefighter's point of view there is what we have here. We had an inlet, in this case it wasn't an AOV, and we have an outlet, and you can see the position of the firefighters. When we introduce the effects of wind, we get that effect. So you've just witnessed that. Those guys were extremely lucky on that day because of wind direction was acting in a favourable manner towards the fire. Now, if you have wind coming from the opposite direction, like that, the inlet and the outlet actually reverse, and the firefighters caught in the middle end up with something like that. And from the point of view of the inside of the fire, that's what they would encounter. Wind-driven fires are extremely dangerous to firefighters, but the point I'm trying to make at this stage is they require an inlet and an outlet. So when we talk about AOVs later, we can see how the AOV, although it has use from the point of view of evacuation of people, the actual smoke management system can pose a significant risk to firefighters. So, the hazards associated with wind-driven events or effects or ventilation flow paths can be intensified by smoke control systems. Now I want to move to fire behaviour in large enclosures. Compartment fire behaviour models that we all use are conceived using small-scale tests. The traditional fire behaviour model is based on tests in small cubic compartments fires with limited numbers of openings. This model is based on an assumption of good mixing of fire gases and relatively uniform fire gas temperatures in the compartment post-flashover. You guys use that in your modelling. We use it in the training of firefighters. And we really represent fire using the standard fire development curve when we talk about the ignition, the growth phase, the flashover period, the fully developed fire and the decay period. But the reality of it is small cubic fire behaviour has little or no relationship to real fires in large volume enclosures. So if you take a look, here be fire tests and look where the real buildings are and the real fire behaviour in those buildings, an awful lot of the assumptions made are blind extrapolations. They're not actually based on real tests. So the other factor is the huge change in the contents of modern buildings, with a preponderance of polyurethane foam, plastics and other materials based on hydrocarbon products, where it's been demonstrated reliably by underwriter laboratories that modern fires burn 10 times hotter and 5 times faster, up to the point of ventilation control. So, the actual fire behaviour in large enclosures follow a different pattern entirely. They don't burn simultaneously throughout the entire enclosure. They tend to burn over a limited area at one time, preheating the next area. These fires tend to burn across floor plates, towards openings, and vertically between floors. And this type of fire development has been labelled travelling fires or progressive fires. To give it that some context, when we look at fires in high-rise buildings, we start to see this type of eventuality, and here's the reality. Travelling fires have the potential to spread at 22 square metres per minute. That's the equivalent of one room every 30 seconds. This does not fit the model that is commonly used in engineering assumptions. This does not fit the model that we currently teach firefighters about fire behaviour. So I want to now talk about fire spread in tall buildings. So the first thing would be pretty conventional and pretty much what we would be used to when we look at ineffective compartmentation, vertical shafts, unprotected service openings, ductways, faulty fire doors and so on. But we now have to introduce the potential for external fire spread with high-rise. So now we're looking at combustible window sets, including combustible transoms. We're now looking at external ACM or MCM wall cladding, rain screen over insulation. We're now looking at external rendered wall systems over insulation. We're also looking at curtain walls with particular attention to perimeter joints. And then one that's very common nowadays is when we have high hazard balcony storage. And there's a whole micro industry after starting in this country with people making the balcony a living space for barbecues, for a lounge area, for sun tanning areas and all this. And if you look at the photograph there, that was an actual fire that we attended that was started by a barbecue.
On a balcony?
On a balcony. So the next thing I want to talk about is air and smoke movement in tall buildings. Well, the principal understanding is the word stack effect, or the phrase stack, and we have a winter stack and a summer stack, essentially causing smoke to behave totally out of the ordinary from what we would expect to normally for going up. And it's all to do with the relative heat between the interior and the exterior. So in a high-rise building, particularly in a summer situation, fire can go down, it can go left or right, and we can have a situation in areas that we would normally classify as the risk zones, the primary and secondary zones for evacuation, that the smoke may not be rising. So the primary risk zone for evacuation may not be where we normally would anticipate it to be, above the fire and the fire floor, of course. So the next thing I want to talk about is lifts and the piston effects of lifts and the effect that has on smoke movement, effectively giant pumps. Have a look.
We gotta get out of the building. Lord, protect my stuff.
I had to edit that because this prayer soon turned to very strong criticisms of what was going on outside. But the message here is the smoke control issues that are created by our actions. The actions of forcing doors, the actions of simply working from protected stairwells to get onto corridors. And one of the biggest findings we found is the actions of firefighters could be creating the biggest danger for occupants. So this is particularly topical, as you know, in Grenfell, and I'm not going to talk too much about Grenfell, but actually managing the smoke that we create suddenly became a much higher priority than we even anticipated ourselves. So I want to talk about some other operational challenges, if I may. With regard to high-rise buildings, the height creates problems for us. Access, first of all, to floor levels above the height of our aerial equipment means that we have to go in. Now, if you look at the current model of command and control, we talk about offensive operations and defensive operations, basically based on a framework of how we analyse risk to the firefighter. With high-rise buildings, we actually don't have the option of doing it from the outside if it's beyond the reach of our equipment. So we can be limited to interior offensive operations only. So the risk escalates exponentially from the point of view of a firefighter. The next thing is the physical challenge. If you have a look at the equipment that the guys are carrying up, we very carefully worked out what equipment we needed, because our toolbox, our fire engine, is 20 floors below. We can't just go down and get something. So we have to bring everything with us. So have a look, each firefighter. His PPE ensemble weighs around 10 kilos. His BA set weighs around 11 kilos. That's 21. And he has to carry 25 kilos of equipment on top of that. That's 46 kilos of equipment. He's also wearing extremely heavy gear, which has a huge insulative effect. So the physiological strain on firefighters is quite significant. The next thing I want to talk about is reflex time. If you look at a standard fire behaviour or development curve, reaching flashover in about 3 to 4 minutes is pretty much the norm in the way we understand it now. Now add in this concept of reflex time. It's the amount of time it takes us to actually get water on the fire. This actually means that our response time, when we include the climb to the fire, is negatively impacted. So what that means to the fire, really it takes 20 minutes from the time of arrival to get water on the fire, along with the original 3 minutes of the fire development.
That's for a taller building, presumably.
For any building. But a taller building introduces the reflex time. It also takes longer to travel from the ground floor sometimes than it did take us to go from the station to the actual building. And because they have to climb several floors, it's quite likely that the fire will have developed much more than we would anticipate in low-rise buildings. So the next thing I want to talk about is communications. Well, essentially they're quite difficult. Radio communications don't work really that well in high-rise buildings. This affects the way we can deploy our crews and communicate with them. Communication to residents is actually impossible. So the luxury they have in, say, the United States, where they have a PA system and advise people on certain floors to stay where they are. They can advise other people to use a specific stairwell, because the fire service are going to use an attack stairwell separately, is a huge advantage. We don't have that on this side of the world. I just want to talk about command and control, and the size and complexity of these buildings require a really large number of firefighters, and it really requires well-coordinated operations in a complex tactical environment. The challenges associated with this are considerable, and we have found from running the exercises that we really have to up our game, and we are doing that right now, but it really creates big problems for deploying resources. Now, the next thing, I just want to move on if I can. I'm going to look at the fire safety features of buildings from a firefighter's perspective, so that's the caveat that I'm adding here. The first thing, the tall buildings require firefighters to depend on the functionality of fire safety features of the building far more in low-rise buildings. Again, if I could give an example, every piece of equipment on a fire engine is checked twice a day, 365 days a year. We're now going to a building that may not have been inspected, it may not have been maintained for much longer than that. And the reliance that we have on the building systems is huge compared to low-rise. So if you look, we're totally dependent on our ability to control a fire is heavily dependent on the standard of construction and the fire safety management of the building. And I don't know whether you guys recognise that. That was Lacanel House in London. If you look where the fire originated on the lower floor and look where it's spread to, you don't need to be a fire engineer to understand there's problems with compartmentation. The next thing I want to talk about is dry and wet riser systems. Basically, there's two standards in the Irish environment, BS 5306 and BS 9990. Depending on which standard, the maximum static pressure on either or is 10 bar or 12 bar. The wet rising systems are pressure regulated to 5 or 8 bar on each floor. And here's the rub. These systems actually limit our capability to fight the fire. They don't actually help us as much as we want them to. Well, why is that? Well, first of all, there's no requirement in Irish regulations to actually specify which standard has been installed. So we don't know. The next thing is that our standard firefighting techniques, which have been developed in Sweden in the 80s and transferred over here, that left us at the leading edge of firefighting tactics and techniques, we can no longer use. So the picture you're seeing there is a firefighter suspending small droplets in the air. In a fire gas-filled environment, it's a hugely efficient way of stealing heat from a smoke layer. It's a hugely efficient way of maximising firefighter safety. We can't do it anymore. We have to go back to old technology because of the design of dry risers. So the next thing I want to talk about dry and wet rising mains.
Sorry, can you explain that? Why?
Okay.
Is it the pressure? Or is it the...
It's a combination of flow and pressure. A fog nozzle needs 7 bar at the inlet to generate small droplets that are demonstrated. We cannot achieve those pressures when we take into account the height, the friction loss in our hose, because we also have this facility that the distance allowable from the dry riser is 60 metres from the dry riser or wet riser outlet, which means that could be 3 lengths of hose. So when we add in the head pressure loss, the height, that is the height related loss, the distance and the friction loss in the hose, we are operating at pressures between 3.5 and 4 bar. So we cannot use the fog nozzle because there isn't a design in the world that will operate effectively below 7 bar. So we've had to abandon the best firefighting techniques in the world because of this. So, dry wet rising mains, The ratio for flow area is 1 to 900 square metres. The flow rate achievable from a wet rising main is 1500 litres per minute. The flow rate from a dry rising main is not specified. The flow rate required to extinguish a steady state burning fire over a fully involved 900 square metre floor plate is 4,500 litres. We cannot even achieve the flow. If you care to look at the writings of Vincent Dunn, a senior command officer in the Fire Department in New York, has actually said publicly he doesn't believe that it's possible to firefight an area over 250 square yards with the water available. And their water available is a lot higher than ours. So that has implications on defensive firefighting. It's implications on whether we're going to put it out or whether it's going to burn itself out. They're just simple facts. The next thing I want to talk about, if I may, is smoke control systems and AOVs. Again, they really originated from the Fire Department in New York, where they actually used to remove the scuttle above a public stairwell to remove smoke. And this has been mechanised and refined with regard to its size and all the rest of it in Europe, right? Have a look at a fire we attended recently. Every single AOV is open. They're only supposed to open on the fire floor. Please throw your mind back to the concept of wind-driven fires, of ventilation flow paths, the concept of an inlet and an outlet required to create a really dangerous event for firefighters, and now look at what we're facing. We have spoke very carefully with smoke management system companies, and this flaw of multiple floor opens, we've been assured, is going to happen in 90% of the dwellings out there because of inappropriate programming. Have a look at each of the AOVs. So if I may, I'd like to talk about the guidance documents. So I'm going to really only touch on one aspect of this, which is pretty topical at the moment. So we're looking at TGDB. We're going to look at BS Treble 91 and effectively how it affects one aspect of our firefighting, which is really kind of controversial at the moment. Stay put. Stay put is explicit in Treble 91. The design philosophy directly impacts on the number and width of stairwells. It's specified in the document. If you take it, in all of these excerpts, I've underlined that it's not implicit, it's explicit. So the next thing I want to join together in terms of thinking is how the stay put strategy or design strategy interacts with the Irish fire alarm systems. Let's look at the Irish one. We have LD1, L3X systems where we have localised smoke detection and an alarm in each apartment. It's supplemented with a heat detector that's linked to the communal alarm. In the UK, which is analogous to the philosophy behind stay put, they have localised smoke detection and they've no communal alarm system in apartments, but they've a communal alarm system activated from common areas only. So what that means is this. The stay put strategy is embedded in Treble 91. This design philosophy allows for limited egress regardless of the height of the building. I've heard the phrase, you can build to the moon with one stairwell. Add in that the fire alarm standard in Ireland encourages full simultaneous evacuation, which is completely at odds with the actual width and the number of stairwells provided. So one is contradicting the other. So what does that mean? Let's give a real world example. This is an apartment block in South County Dublin. 16 stories, a single stairwell. There's 4 apartments per floor. There's a wet rising main. There's an L3X system. We have a smoke shaft in the corridors with the controls in the corridors, which we could talk about all night. It's a separate argument. They have an AOV in the stairwell. They have a 2-storey underground car park. Let's have a look at the size of the stairwell. I'll ask you a question. If you're a resident there, do you think you'll get out? If you're a firefighter, do you think you'll get up while people are getting out? And I can say honestly, not a hope. So, the escape routes, from our perspective, are most likely to be heavily congested with evacuating occupants during DFB operations because of the contradiction in the amount of escape routes and your alarm system. This could compromise both the evacuation and the firefighting operation. It's not possible. So, here's where we are. Right, so I'm going to use an Americanism here. The known knowns and the known unknowns from a controversial American politician.
Great man.
Wonderful man. In a 100-year design life of a building, the design and construction occupies 2% of that philosophy. 98% of it is based on management of that building post-construction. So from the point of view of Dublin Fire Brigade, we have this question. How well do our buildings actually comply with the building regulations or the design intent? We're not so sure. How good is the fire safety management post-construction? We're not so sure either. So let's look at the challenges that we have. When we put it all together, we realise that we have concerns about the stay in situ design strategy, which is quite popular discussion in the UK right now amongst the fire services. The stay in situ design strategy, as opposed to a firefighting strategy, was served them very well for 30 years until events in the last 2 years. To such a degree now they're really questioning it quite hard, as do we. We have issues with smoke control systems on the assumptions that they're installed under with regard to the amount of smoke that they're supposed to deal with, regard to the actual amount of smoke that's going to happen. We have issues with the dry and wet riser systems in terms of the flow that they can give us and the pressure they can give us. We have concerns because of our knowledge or operational understanding of the level of fire safety management in the buildings that have been built, and we have concerns about compartmentation. So what are we going to do about it? It's easy peasy, isn't it, really? So we've looked at this really hard, and the first thing we did is we took a really strong and hard look at ourselves. So the first thing we did, we spoke to our international colleagues. We spoke to our British counterparts, our American counterparts, and we tried to understand what they had gleaned from real-world experience. We carried out a literature review of international best practices. We studied every standard operational guideline that we could lay our hands on. We looked for convergent teams. We looked for the teams that that went different directions. And then we looked for emergent teams to see what we could actually see what the future will hold. We then identified, and I stress the word, realistic high-rise emergency scenarios. We made assumptions on what we believe actually happens rather than what might turn up in a discussion. We then undertook multiple full-scale exercises, averaging one every 8 weeks, and we made an honest appraisal of our capabilities. The discussion that I'm having with you tonight is very much a cleaned up version of how we look at ourselves. Behind the scenes, the fire service in Dublin are hypercritical of ourselves, and we really strongly work to improve and not sit on our laurels. So let's look at this. This concept of realistic emergency planning assumptions is based on Homer Simpson. It's based on human factors. It's based on what people do when they're being silly, when they're being careless, when they don't follow the rules, when they wedge open fire doors, when they take away door closers that were installed because they don't like them, when they store materials in corridors and on balconies that they're not supposed to. So this is what we came up with for residential buildings. The first planning scenario was smoke-filled stairwells. Think about that for a minute. Has any of you guys considered that? We then thought about the stairwell might be clear. The AOV may actually work. It may be not nailed closed. They may be not disconnected. They may have been serviced recently. The residents in that apartment block have paid their management fee to allow the management company to service these items. Next one, we looked at the apartment or the attack corridor is smoke free, and then we looked at the opposite, that the corridor might be filled with smoke and people can't escape. We then looked at a multi-apartment, multi-floor structural fire. We actually had one in reality, as you know. We then looked at some commercial building scenarios, and we thought about travelling fire or a progressive fire in a single floor commercial building. Then we looked at a multi-floor commercial fire. We then looked at wind-driven effects, and then we looked at underground car park fires. So then what did we do? Well, we came up with some key principles, and these key principles are going to be the bedrock of how we're going to approach this for the next 40 years. We determined that operational intelligence driving evidence-based decisions and practice. We determined that a rapid intervention and effective water application is the only way forward. We need to do this really, really quickly. And we want to be the fastest fire service in the world at getting water on high-rise fires. Not the second fastest, we want to be the best. We then came up with this stay in situ. No. We've determined that it is not the best actions for Dublin Fire Brigade at this current time. And we believe that the only option available to us logically is the concept of simultaneous fire attack and phased evacuation based on a risk profile of a primary risk zone and secondary risk zones I'll talk about in a minute. So we also identified development opportunities. We really determined that we needed to enhance our command and control systems and to adopt evidence-based firefighting tactics, not hearsay, stuff that had been studied and has been proven through quantitative evidence. We needed to improve the manner in which we gather and disseminate operational intelligence. We need to minimise our reflex times. We need to enrich our knowledge of building systems. One of the big learning points were we really didn't understand how these buildings were put together by you guys. We didn't talk enough. So we realised that we have a cognitive learning opportunity there. We then realised that we have to get really good at deploying hose in narrow firefighting shafts, which is not the way firefighters are trained. They're trained on big open training yards. We then realised we had to get really good at operating firefighting lifts and the safety implications for using them. We had to change the way we put out fires because we can't use fog nozzles. And the way we rescued people, the general trend in a rescue operation is the firefighter will go room to room to room. We quickly realised that that's not feasible, that we may need to go to an apartment on one floor and immediately go to another apartment on a different floor, which doesn't fit into directional searches or linear searches. We really need to understand how high-rise fire behaviour is going to implement the flow rate achievable, impact on the flow rate achievable, and how we're going to put it out, how we're going to deal with it. And then the big thing is, Dublin Fire Brigade is a fire-based EMS. On this side of the Atlantic, nobody has looked at how your ambulance service and how we're going to treat people, triage people in a high-rise environment. Nobody's looked at that. You won't find it in the UK. So we wanted to integrate our entire operational assets in this. Now let's just look at a couple of these, and we're coming to the end of this really. The first thing, with regard to enhancing our command and control at high-rise function, high-rise incidents, I'm going to just give you some demonstration of the evidence-based tactics. There's a huge amount of research going on in the United States by underwriters' laboratories, looking at modern fire behaviour, modern fuels, different tactics. And I was lucky enough to be part of a technical panel for underwriters' laboratories for a period of time in Chicago. And they're really doing some ground-breaking research that we can use. With regard to command and control, the first thing we have to think about is what are going to be our key strategic objectives. And here's the first one. The primary objective that we are going to work on is maintaining occupant means of escape, so that during our operations that people can continue to use the protected stairwells. This is not as mild an innovation as you might think, particularly when you think about what has occurred to our colleagues in the UK. The second one is, how are we going to do that? Well, we're going to use an innovation developed by Professor Michael Reich in Germany called the smoke curtain. And the smoke curtain is a device that you can mount on stairwell doors or apartment doors that allows us to open them without smoke escaping into the corridors or the stairwells. We've tested this extensively over the last 2 years at real fires, and it's just a fantastically effective and simple piece of equipment. We're also looking at using electric fans for stairwell pressurization to enhance or maybe replace the built-in systems in buildings. The reason for battery-powered fans is they don't produce carbon monoxide. The smoke curtain looks like that. It does what it says on the tin. A simple framework that expands on a telescopic tube. We can mount it on the door, and it allows us to do something quite unique. It allows us to carry out a fire attack and at the same time protects other people's means of escape. Throw your mind back to the video of New York, that as soon as they open the door by forcible entry, that escape route is gone. It's finished. Whereas with this simple technology, which has been in Germany for 10 years, it's on every single fire truck in Germany. The insurance industry paid for 50% of them because of the savings in actuarial losses. It works. So, let's have a look at one use of it. This is a hospice fire in Dublin, 2017. And if you look at the room of origin, from both inside and outside, this is the corridor for escape. So we can see that people could still leave while we're fighting fires. That is a really significant development for the fire service. Okay, the next thing with regard to enhancing our command and controls and strategies, the concept of a simultaneous fire attack and phased evacuation is going to be a cornerstone of our approach here in Dublin. We will not be depending on stay in situ. How are we going to do that? Well, we're going to use the smoke curtain, but we're also going to evacuate a primary and then secondary risk zone. So the primary risk zone, we will simultaneously mount a fire attack on the fire floor in that apartment and evacuate all apartments adjoining on that floor. We'll also make sure that the stairwell remains clear. For the most part, that will be most fires we attend. If the fire has developed hugely, we will then consider secondary risk zones depending on stack effect. So it won't always be the floor above, it depends on the smoke travel. But the next floor will be the secondary risk zone and so on. With regard to decision support, if any of you guys have been following the Grenfell inquiry, you, particularly at the early stages, the first arriving officers, you will actually experience the sheer stress that arriving officers experience at multi-casualty incidents. It's hard to explain unless you've actually experienced it. What we've done is we've looked to our colleagues in the UK and Kent Fire and Rescue who've come up with a heuristic or a decision support matrix, if you want, called the RICE model. On this particular slide, it looks incredibly complex, but it's actually based on 4 concepts: rescue, intervention, evacuation and containment of a fire. Those decisions are based on predetermined triggers which allow the officer make really good decisions of what to do, whether a total evacuation should be your focus. This is a once hopefully in a 50-year fire, or whether the rescue or the intervention or containing a fire on the fire floor are the best options. I actually worked with Kent recently on this, and I can assure you it works really, really well. The next thing, in terms of enhancing your command and control, the key strategy, prescriptive tasking of arriving resources. In general, what happens in the fire service is that as the officer makes decisions on scene, he allocates the resources in a very flexible way. This flexibility is essential. What we found is this is actually impossible in high rise. So we've done a core and critical task analysis of the duties and responsibilities of each arriving motor. So what's going to happen is, as the vehicles arrive, they will be given the job of vehicle 2. They will be given the job of vehicle 3. And we've tested this over the exercises. This is what's done in New York, and it works. And it takes all the expectations and frustrations of an officer. Is he doing the right thing? The next thing with regard to command and control, we've looked at best practice, and we now establish localised command hubs, both in the lobby, the bridgehead, in a firefighting or search sector, command support, and in planning and logistics. Predetermined roles in the command structure, predetermined positions in the building, actually cuts down on reflex time and improves firefighter efficiency. Have a look. This is a piece of equipment developed in Sweden at 70 litres of water a minute. Given that most of our tall buildings will be type 1s, our turntable ladders will be able to apply this by using an electric drill. And because of its design, and that it will be an exterior water supply and pressure, we can generate pressures of up to 40 bar and generate droplets less than 0.3 of a millimetre, and it gives incredible efficiencies. So we can actually start our firefighting operations from outside. Our intent is to expand the performance envelope of our aerial equipment, which are normally heavy hitting equipment when the roof is gone, to exterior firefighting while the guys are trying to get up the stairs with 45 kilos of equipment. So we're going to reduce reflex time. Have a look at this technique. Straight stream tactics from outside at a very high angle produce a surfing effect. Have a look at the effectiveness within 7 to 8 seconds of fighting the fire. This came from Underwriters Laboratories. You might say, sure, haven't you been putting water on fires for years? The very specific, very high angle with a straight stream only keeps the vent working. It allows it to let steam out, and it has a fantastic cooling effect. Again, if the window's broken, our turntable ladder can be doing that while the guys are actually on the way up. That might seem a fairly trivial thing until you realise the historical methodologies that we've been using for years. The next thing, the problem with dry risers. We've had to return to technology that goes back hundreds of years. Simply a pipe, a smooth bore. We've generated a lot of thought, a lot of learning development, how we can maximise. But given the nature of current dry risers, we've had to go backwards to go forwards, if you excuse the cliche. The next thing we're looking at, and we've actually bought, is a floor below nozzle. There will be occasions that the highest turntable ladder in the world cannot reach a certain building because of its height, setback and location. The floor below nozzle will allow firefighters to actually attack fires on a fire floor when conditions are untenable, maybe because of wind-driven effects, maybe because of a failure of compartmentation. This will really fit into a scenario where we can accommodate a firefighting action even if our turntable ladders will not fit. The next thing we did, if you look at a standard hose in Ireland, it's in a roll, and you see firefighters rolling it out. It doesn't work in high rise. It doesn't work in stairwells. So we looked at 4 different systems: a bag system from Australia, a bag system from Canada. We looked at a thing called a Cleveland load from the United States, which didn't work at low pressures, and we came up with this type of hose load. It works extremely well in narrow corridors. The next thing we did was standardised high-rise packs. We don't want people going down for pieces of equipment that they may need later on. So each crew will carry a dedicated range of equipment, and the load will be distributed equally between every member. We literally weighed the guys and the equipment going on to ensure we could get the best ergonomics and the best load distribution. The next thing we have to do is we've actually developed a draft curriculum of high-rise firefighting on all aspects, cognitive and psychomotor. We are in the process of designing a high-rise training prop. All cognitive and psychomotor skills will be taught using a combination of e-learning and face-to-face training. So just to summarise, and I know you just need the main ideas here. The current city planning documents confirm a policy to consolidate and expand the city through high-rise development. It's going to happen. We've got a clear understanding in Dublin Fire Brigade of the challenges that present for firefighting in tall buildings. We've identified development opportunities for improving our operations in the modern built environment. And I'd really like to finish it by summarising a comment by Peter Senge, and he says, through learning we create ourselves. Through learning we become able to do something that we were never able to do. They talk about learning organisations, and they talk about that usually in the context of commercial competition. The nature of the fire service means we're constantly changing. We are constantly reacting to the built environment and the changes in it. I just want to assure you that we know we're not there yet, but I can also assure you we're absolutely determined we're going to get there and provide the best service for the citizens of Dublin. Thank you so much.
Thank you very much, John. We're now going to have a Q&A session. Format's going to be that we've got two mobile, once I turn them on, and we will hand them out to who wants to ask questions. What I will ask is that the question has to be asked through the handpiece. Can you do this side? And I'll do the far side. So if you can think of your question, how you're going to word it, pose the question, and then give John an opportunity to...
And then pounce.
If you don't mind, I'm going to start. It's Kevin Woods here. You mentioned at the start of the talk the difference in the Irish built environment relative to the UK or to the US. You might explain that, please. And then the other question was, how many of these type of tall buildings do we have in the country at present?
In the country? Okay. First of all, the American system, they've been doing high-rise for a long time in the United States. And generally speaking, they'll have more than one stairwell. That's the first thing. The next thing is where they place the dry risers. The dry risers are not placed in stairwells or in lobbies, they're placed on the corridors. And the next thing about the American high-rise environment, they have a public address system in every single one of them. And they tend to control evacuation by voice. I would also say that their understandings of how a fire is behaving in those buildings is probably in advance of ours right now. But in terms of the built environment, they're certainly a lot higher. And essentially the tactics that they use are really driving the way we're approaching this. In the UK, I mentioned the differences in their alarm systems. I think there's a proliferation of external cladding systems that we don't have in Ireland right now, which I'm glad to say. And I think it has changed the face of British firefighting in tall buildings. In the Irish, we haven't got as many high-rise buildings. I cannot speak for the country. And if I'm being honest with you, off the top of my head, I actually even can't speak for Dublin. But what I can say is most of the developments that we're practicing for will be type 1s, which in Dublin will be multiple occupancies up to 20 metres.
Okay, the reason I was asking the question is just wondering from the point of view of retrofitting sprinklers into buildings, because sprinklers weren't mentioned and sprinklers would prevent all of this in the first place. But of course, good fire prevention would as well, and maybe education about not wedging fire doors, but retrofitting sprinklers and sprinklers in every new building. I'm from the insurance business, I should say, so that's part of the reason why I like it, but also it has a knock-on effect for my life sake.
I would agree, and if you asked a personal wish list of what I'd have in the buildings, I would have dry or wet rising mains with a minimum diameter of 150 millimetres. I'd have a twin outlet on every floor, because at the moment we're carrying up something to adapt it. I would ask that the smoke control systems can actually deal with the real amount of smoke developed. I'd ask for that there'll be PA systems, or at the very least that the alarm systems would have a fire crier system, you know, where that actually tells people to get out. And I would like to see changes personally in the way we build them as well, because I think it would make our job an awful lot easier.
Hopefully somebody from the Department of the Environment is listening and might write it into the next TGB if we ever see it. Again, just going back to sprinklers, I think if you put sprinklers there, none of this would be necessary.
Absolutely, yeah.
That's the other thing. Anyway, thank you very much.
Thank you.
Hi John, it's Niall Murphy. John, could you just talk a little bit more about, you just mentioned about legacy furniture and modern furniture and the difference in fire behaviour as a result of that in terms of speed and flashover and all that kind of thing.
If you look at pre-1970 and look at the furnishings of people's houses, well, you're looking at organic materials like cotton and linen, and the upholstery may have springs in it. You're looking at basically low energy fuels. In terms of fire behaviour, that gave off very, very little smoke. If you did a direct comparison, there's a great video, and just compare legacy to modern fuels on YouTube, when you're looking at the actual the amount of polyurethane foam, if you look at the amount of plastics, if you look at the amount of materials that have their raw material in hydrocarbons, the direct comparisons made by underwriter laboratories up to ventilation control, that the modern fuels will burn 10 times faster. So you're looking at flashover in around 3.5 minutes, whereas it will take about 28 minutes in the legacy fuels. The smoke production will be much, much less on the legacy fuels. The other thing I'd say is there's no European standard for furniture padding. Doesn't exist. We had an agreement with the UK, and they're leaving shortly. Leave us on our own. And some studies done by a Dutch company, they call it areyousittingcomfortably.com, where they did an analysis of all European furniture, and naturally everything that they burnt wonderfully, or awfully, depending on your point of view. And they took the British stuff, and because they sprayed the polyurethane foam, it actually was very good. And the Irish stuff was tried then, it burned worse than any of them. And they found that it was originally built in Holland, exported to Ireland, and brought back for the tests. So it's an issue of enforcement, which is quite surprising in this country, because we're really good at it. But regarding the modern fuels, you're looking at, old fuels, 30 minutes to flash over, modern fuels 3.5 minutes. In terms of heat release rate, up to ventilation control now, you have 5 times greater heat release in modern fuels compared to the legacy fuels.
John, my name is Forrest Cooley. Do your tactics take into account the construction of the building, whether it's masonry, whether it's steel supports, or whether it's timber frame?
Timber frame, let's talk about that. Timber frame creates problems for us. As you know, you have an inner leaf and an outer leaf. The inner leaf supporting the weight of the structure. Timber frame, we've developed standard operational guidelines. The fog nail that I showed you, you know, the device, we find that conventional firefighting doesn't work, and that we need to identify the source of the fire with a thermal image camera. We need to drill a hole of 20 millimetres directly where the heat is at its most, and then inject high pressure water spray directly to the seat of the fire. Conventional firefighting doesn't work with timber frame. With regard to steel frame, no, the answer is no, because first of all, when we arrive right now, we won't know the difference. Where's that shell? I can't actually see it. I didn't see it there. So at the moment, we're working on the basis that we're going to get a rapid intervention. We're working on the basis that we're going to do simultaneous evacuation for every building. We're going to prioritise our deployment of crews in a predetermined manner. I can't really go any further than that because we didn't take into account whether it's steel or otherwise.
John, I've got a quick question. It's in relation to B5 of the 5 billion regulation. The fire brigade access to the actual site itself. One of the things that was obvious from the Grenfell fire was that as more and more of the fire brigade vehicles arrived, there was less and less room for everybody.
Yeah.
But equally as well, the actual Grenfell site, I visited the site, and it was the grounds of the site was in a housing estate effectively. And it was very, very difficult for fire brigade vehicles just to get in there alone on its own, let alone with vehicle after vehicle after vehicle. So what would be your your views in relation to fire brigade access, because currently the Department of Environment is looking at reviewing their advice to planning authorities for high-rise and tall buildings, and it's out to public comment if people want to make comments to see whether the department will revise their advisories to the planning authorities, and they're the ones who decide what gets built around these tall buildings. So in your analysis, have you looked at that in terms
Yeah, we did.
of...
What you've seen in that presentation was a very much sawn-off version of what we looked at. Access is a big issue for us, and it's based on, if you look at the way fire engines have evolved over the last 20 years, they're much, much bigger. They're mostly on Scania bodies now, and they're very large vehicles. The access is a big issue for us, as it was for London Fire Brigade, and we would certainly be looking at any opportunity to revise that.
John, hi, Sheila Robert, Meath Fire Service. Firstly, well done on the project and all the extra work that was done by the Fire Brigade, and we're all have a lot to learn from it. I suppose everybody in the fire service is trying to work on prevention and doing pre-incident planning and learning more about the building stock that we have. One of the issues obviously is that I suppose the systems that we're using to do that are a bit archaic, and we're not using building information modelling and these things. We don't have really up-to-date information on buildings. So I suppose we're kind of fighting losing back and we're trying to have accurate information on building types. And the other thing is, and I'll come to the question in a minute, the other thing is that the building occupants, I suppose, are living in more complex buildings and maybe don't always understand the buildings that they're in. So the first question is there anything being done in terms of the project to improve the information that's being gained from the buildings and how to keep it up to date? And secondly, in terms of building occupancy, do you feel that there's a need there for building occupants to be more engaged in terms of understanding the limitations of the buildings that they're occupying?
It's a really good question. We have a separate team working on operational intelligence, and the big issue is when you think during the planning process and the application for fire certification, the amount of information we generate there. So what we're looking at is to improve the efficiency between that point of information to start with, and then with our operational crews to familiarise themselves with the information in that they need. I know they don't need all of it, but from the point of view of command and control, what we're looking at is premises information plates in an electronic manner. So in other words, about 10 years ago we wanted to get these placards on buildings giving us a very short heuristical analysis of the building from a firefighting point of view. So what we've decided now is that we certainly will encourage that. We're going to put them as an EPIP. In other words, that we're going to be tablet-based information, that the very first page of the pre-fire planning will be an electronic premises information plate. And we're going to follow that up by placing a very small version on the fire alarm in the building in case there's any issues with people that don't want a big placard outside their building. We're going to put it on the fire alarm panel in about that size, because it should be the first point that the officer should see when he arrives. And thirdly, with regard to residents, we've identified two things. First of all, pre-fire and post-fire. We're actually setting up a program that we're going to go around to buildings, engage with the community. But one of the things that's coming from our American colleagues is that if a fire occurs in a building, that has turned out to be a really good time to get the people together and talk about what they can do about it going forward. So we are actually looking at this quite holistically, but it isn't going to happen in weeks or months. And we've actually dedicated a very small professional group of a district officer, a station officer and a sub-officer with professional qualifications that are going to head up this particular department. So first of all, we've resourced the actual section in Dublin Fire Brigade to look at this and have the people to do it. And we've actually looked at it over a period of 2 years where we're going to map every building in the city in a detail that nobody ever has before. So the plan then would be, with the type classification that we've come up with, the very simple radio message to an officer: you're going to a type 2. It's over 20 metres. It's beyond the reach of an aerial appliance. It's going to have a protected stairwell, an AOV system. It's going to have a dry riser. It won't have a rising main. The type classification, we believe, getting back, and I'm overusing the word heuristic, at the moment we've rafts of information that are not useful in a fast way. And I think we need to apply a psychological approach to how we can package the information we have that's useful, because I can tell you now from operational experience, the concept of opening up a laptop, letting it boot up, finding a building and going through tons of information to find really, really particular information we wanted in the first place is something we need to speed up. And the word that we're using is fast, frugal heuristics.
Yeah,
So we're
I suppose like we have to catch up, and technology has improved so much that we're just not there.
Yeah.
There's so much there in building information modelling that we could be using to help ourselves. I feel that we could be doing a lot more.
Yeah.
And I don't know if really building owners and occupants are as engaged as they should be, and maybe that's that we can't just do this ourselves. You know, there has to be, we have to have other people
Community
involved,
based,
and
yeah.
but we need to try and push that more.
Completely agree with you.
That's it. Thank you.
Relay race.
John, Grant Masterson, great presentation and well done on all the work that you've put into it and DFB included. Has this been shared with the retained stations and the retained counties around the country at the moment?
The project is ongoing.
I come from a retained service background.
All right.
And over the years we did a lot of training. Some of the equipment that you showed, especially the smoke door for instance, was shown to us in training maybe 8 years ago.
Yeah.
By the German training
Yeah.
company as well, but was never provided to the fire service. PPV fans were provided, training, all sorts, but the equipment never followed. What you're talking about, the type 1 buildings would probably be the most common
Yes.
around the country. So is there has this information, been given to the rest of the country?
Well, the first thing, I probably maybe never emphasised this enough, this project's not over. It's still ongoing, and the stage it is now is we're going to England shortly to look at their training facilities with the view to, I wouldn't say copy it, but to certainly use the information they've learned. The plan that we have is to send a group of 12 instructors over there. The next phase is we're going to train every district officer up as a tactical advisor to get a footprint on the ground. The next thing we're going to do is we're going to embed it in officer development courses, and we're going to include it in recruit courses. The actual sign of success of this course is when it disappears. And I'll tell you what I mean by that. We don't want high-rise firefighting gurus. We don't want, that's the firefighting group over there. We want everyone to be of an equal level, that it becomes normal firefighting. But to answer your question, Dublin Fire Brigade have never been shy about sharing information. We've pioneered a lot of work on smoke curtains, PPV, fog nails. We're running a course on the 5th of November for Carlow and for Cork Fire Service with regard to new tactical and new technology and the innovations that brings to the fireground. So what I would say to you going forward, when we get to a level where we're comfortable that it's starting to disappear, we're very happy to share it with anybody.
Thanks very much. I suppose something that you talked about was the American UL. I was at the conference last week and I saw some of the videos that were shown from what they're doing, their test facilities, their training facilities, the testing of the firefighters in real fire situations like this. It's years ahead of what I had experienced and what we would have ever dreamed about in terms of fire training and fire facilities. So it is great that Ireland is involved with this.
I think we're lucky as well. I think we're open-minded. I think in certain countries they believe that their way is best, and they sometimes mightn't be as open to ideas from across the planet. One of the things that as a community of Irish people, I think we're far more open to, well, I think that's a really good idea, let's take that. But UL, under Irish Laboratories, if you get a chance, what a body of research that they've provided free to the world. And I really think that the whole purpose of this is to start a conversation between the professional engineering groups and the fire service, the active firefighters, because it would appear to me that some of the deficits that are occurring is because of a lack of discourse. And I really think that this hopefully will kind of act as an impetus or a catalyst to that.
Brian Geraghty, I'm a building services engineer, so I'm going to be oddball amongst everyone here. Again, your talk was excellent, and a lot of information there, a lot to be absorbed. So, as a building services engineer, I'm involved in the design of the services within buildings, and I was very interested in your comments on dry lighters, because at the moment I'm involved in a few projects that are refurbishment of buildings, including the fire safety features of the building, and also gas distribution within buildings, which is can be a potential problem, and the isolation of gas supplies. I suppose rather than ask a multitude of questions, my real question is how will all of the information and the knowledge that you've gained through all of your work be transferred into building regulations, and eventually come down to people like me who will be at the coalface in designing the buildings that will comply with your desires and be safe for your people to enter?
Well, I'm going to really disappoint you here, because it's a really well phrased question. My remit and our remit in the group, the project group, was to really take a firefighter's perspective on it and remain unpoliticised. And if I'm being honest with you, maybe the people you should be talking to there would be Dan, or maybe some people in the department. But we're hoping that to start conversations. That's all we can do. So I'm not going to respond to that. First of all, I don't have the competence to respond to it. But I'm hoping that the events over in the UK and the work being done by Dublin Fire Brigade will certainly influence their thinking, and that's just an aspiration at the moment.
Can you see it being transcribed into regulations here? Because one of the problems we have as engineers is that a lot of the requirements or conditions within buildings that we've got to design for are not clearly identified or clearly described within either our TGDs or within the standards that are quoted. They go so far, and you're on your own after that.
Yeah.
With regard to dry risers, are you for or against dry risers?
Oh, I think they're a great idea, but I don't think they're designed properly.
I agree.
And I don't think we're having a conversation right now in Dublin Fire Brigade informally about where we should place outlets. I certainly think 150 millimetres should be the minimum diameter. I think the pressures coming from wet mains and the way they're pressure regulated should be a lot higher. And I think the amount of flow available for the floor areas that they're actually designed around, 900 square metres, is far too small. Far too big for the amount of water you can get out of them. So I really think they're a fantastic idea, but it's like looking at an old car. You could do with a lot of modifications.
Okay, thanks very much.
Have we got any other questions? I might just make a comment that the next version of technicalguides.mb has not been published yet. So quite possibly there still is an opportunity for people to make comments to the Department of the Environment that might incorporate some of the lessons learned from various fire brigades until the actual final version of TGDB is reviewed and published and made public to us all, which we are eagerly awaiting if anybody's listening. Anyway, if there's no further questions, I'd just like, on behalf of the Fire and Safety Division, is to thank John for all the effort that he's put in. Thank your employer, Dublin Fire Brigade, for making you available and making yourself available on this evening, cold night. Engineers Ireland are now giving every speaker a copy of a book called Engineers from the Great Pyramids to Spacecraft. I wish it was something more exciting, but at least it'll be a bit of evening reading, John. And thank you very much.